I'm Kristie Mann. Been here with Stephen on this forum a couple of times. So today I promised we would come back and talk to you a little bit about our Optane and CXL strategy. This is an exciting topic for us, and we're all excited to be here, joined by some of our common customers who are collaborating with us on this journey. So let's go ahead and dive right in. So tiering is the way that we view this market, and tiering is the way that you can optimize your capacity, performance, and cost. We view this in terms of data tiering. It's not memory tiering, storage tiering. It's just in general data tiering. And we've been on a journey for the last several years at Intel to bring you a combination of CXL plus Xeon plus Optane, so that together we have an excellent, cost-effective, high-performance, scalable architecture for data tiering. We're also leading innovation with our Optane product line and using it as a vehicle to get the benefits of CXL. So we're going to share with you today a little bit more on our long-term roadmap for how we see this evolving since we began years ago, all the way through our 4th generation of product. And we believe that Optane is really unique in that it unlocks the business value that our customers are trying to do by being an excellent middle tier between DRAM and NAND. And it's enabling a lot of new solutions. And so you'll hear about that more today from some of our customers. So how do we view this market? Our view of memory and storage is really centered on workloads at Intel. And you can see that you have a range of different workloads that all intersect different tiers within that data storage, memory and storage hierarchy. Typically, Optane is positioned in that space between DRAM and NAND, but I want to reiterate that at Intel, we're also looking at things like in-package memory, high bandwidth memory, cache improvements up at the SRAM, in between SRAM and DRAM. And the Optane SSD also works down as a storage cache as well. But we've been on a multi-year system-level strategy for Optane to optimize that tier between DRAM and NAND. And what we're seeing is that the workloads themselves are changing so that the usages demand a lot faster access to more data. This is a common problem across the industry. As core counts increase, we're going to see more and more pressure to feed those high capacity and high bandwidth compute workloads. And so we believe that this tier that we're introducing is really going to help change the game for these workloads. We're approaching it from a hardware and software ecosystem point of view. I'll talk you through that today. But memory and storage is really needed to feed those compute cores, and we believe Optane helps fill that gap between DRAM and NAND. Okay, so if I look at our multi-generational approach, I want to kind of take a step back and talk to you about this journey that we've been on. Our strategy spans more than a decade of development and industry influence. It started with the media itself, and we put this in the phase of laying the foundation even prior to our Gen 1 product. That media itself is unique. It allows dense, affordable, byte-addressable, non-volatile capabilities, and it opens up a lot of new use cases. We started laying the foundation in over 10 years ago. While the media was in development, we started working with the software ecosystem. And Andy's going to talk to you a little bit more about that, but with an open programming language that we developed through SNIA, with libraries, and then with our partnerships across the industry, with the ISVs and the OSVs, we also have been working to optimize the software to take advantage of these new memory tiers. We then carried it further by influencing the hardware providers, the appliance vendors to design persistent memory and Optane SSDs into their appliances. So it's a very comprehensive approach. We entered the market in 2017 with SSDs, and then in 2019 with the first generation of persistent memory. And these were very targeted products using the DDR-T protocol for the PMEM, and using NVMe for the SSDs. And we were going after very limited workloads. In generation 2, we started working on expanding that ecosystem. So moving out into more workloads like custom cloud, software as a service, financial services, and you heard us talk about DAOs about a year ago in this forum. And then with generation 3 of our persistent memory product, you're going to start seeing some performance improvements and some features in the roadmap that Allison and Andy will also talk about, where you're starting to see some real performance gains and moving into new workloads like AI and analytics for cloud, using accelerated memory and more usages. Our long-term approach has been to get to memory tiering over CXL because you don't have to share the DDR bandwidth. CXL is an amazing capability. Andy will fill you in on that. And at that point in time, and this will be our 4th generation of product, we'll be much more successful in general purpose IaaS, infrastructure, and even moving into some of these future use cases like memory pooling and tiering. So let me talk a little bit more about, let me pull it all together for you, about these innovations. I think that we've taken a really comprehensive approach. We have been and continue to invest in a complete memory tiering ecosystem. I'll start on the left with some of the hardware innovations. With Optane, we actually put part of the memory controller in the Xeon processor. So we've come out with all sorts of memory control optimizations right in the Xeon processor itself. Across Intel, we have groups working on high bandwidth memory, in-package memory on the SoC, hitting some of those other tiers of the hierarchy. And then with Optane, some of the innovations we've brought have been the media itself. And then at the system level, these new tiering, caching, and memory tiering use cases. On the software side, some of the other innovations include modes, libraries, that open source programming language that I told you about, and then our work with the ISVs and developers. And then behind the scenes, we've also been driving some of the standards like CXL and PCIe and NVMe. We participate in those bodies, and the protocols like DDRT and DDRT2. So what you're going to see is that all of this work that we've been doing to build this ecosystem together is going to be transferable as we make this transition over to CXL, because a lot of the same programming languages are used, and we've been preparing for this for a very long time. All right, so what does this look like from a roadmap point of view? I've actually shared this slide with you guys in the past, but what I really want to focus on is that you can see I'm bringing the 3 portfolios of products from Intel together and trying to show how they intersect. And you've got the Xeon roadmap along the top. Our 1st generation of persistent memory came out with Cascade Lake. We then targeted Cooper Lake and Ice Lake for our 200 series. Coming near the end of this year, we're going to have our 300 series, and that's coincident with Sapphire Rapids. And what you'll see here is I've put a mark on there that says CXL 1.1. In this time frame, it wasn't, the capabilities of CXL 1.1 weren't adequate for Type 3 memory devices, and so we've been planning to intercept CXL 2.0 in a future generation of the Xeon scalable CPU. Right now, we're targeting Granite Rapids, and that will be the first CXL 2.0 compliant CPU from Intel. And at that point, that's when we want to have a CXL type of device for persistent memory in that time frame. Along the bottom row, don't forget, we still continue to maintain the storage product line. The Alderstream P5800 is ramping very successfully. This is the world's fastest SSD. All right, so that's a view of the roadmap. So, in summary, we've been on a multi-year journey, 10 plus years of software programming models, application software optimization. We started with our early products, SSD first, PMEM over DDRT, but in the background, we've been working with the standards bodies. We even helped found the CXL consortium. Over 150 companies are now a part of that, and we help drive influence for capabilities there. We've been working diligently and investing in working with partners as far as ISVs, OEMs, cloud service providers, And we've been working on the development of a CXL attached device to go into that roadmap. This roadmap of products have been designed to gradually, remove barriers to adoption. And the ultimate goal has been making it easier to adopt CXL attached data tiering in the system. So at this time, without going into details with this, I want to introduce Andy Rudoff, who probably needs no introduction, and Allison Goodman. They are both our technical senior fellows, very, very knowledgeable on this. And I just want, Andy, do you have anything you want to chime in here about the roadmap or about the software?
Thanks, Kristie. Yeah, sure. Talking about the roadmap is important because I think it shows that even as the ecosystem expands to using more persistent memory year over year, we're still looking for things that we can do in the roadmap to help that cause. And the things you see listed here, like optimizing the power utilization generation over generation, or making finer granularity access to our media. That's the cache line access size that's mentioned there. These things are largely transparent to software. They give you a better overall picture. And so you find that if you've have an application that can leverage persistent memory in one generation, when it gets to the next generation, things improve even more. And the right-hand side of the slide is really trying to bring that home and say, with the move to CXL, we make another kind of big leap of improvements for software. And so I'm gonna talk about that in more depth in the upcoming slides. So first of all, let's do a quick review about CXL, Compute Express Link. There were competing ideas on a better way to attach accelerators to hosts. They were not compatible. They were being handled in different venues, and CXL really pulled that together and gave us an industry-supported processor to accelerator link. Like Kristie mentioned, it's something like 150 companies. It's actually really been a lot of fun for me to participate in because we have all the major operating system vendors, the major system vendors, all these major device vendors working together on this one standard. It does leverage a lot of PCIe. It runs on PCIe electricals. Things like how you find devices in the system and how drivers get loaded, things like that. That framework is leveraged. We build on that instead of wiping the slates clean and having to start all over again. So that's also a huge benefit over the design of CXL. CXL on those PCIe electricals introduces several protocols that I'm going to show you on the next slide. And these protocols give you quite a bit of flexibility on what type of devices can be built and added to CXL. So why did we do this? Why is CXL needed? Really, scalability is the first thing that comes to everybody's mind. You run out of DDR channels at some point when you're trying to add more memory with today's demand for memory. There are limits to what you can do by adding accelerators to PCIe. PCIe is not cache coherent. It's you kind of have to do block access or have a DMA engine or things like that, where CXL really gives the accelerator a way to be more of a full citizen of the host, as you'll see in a minute. So a lot of this design of CXL has really been about efficiency. It's been about trying to find ways of adding these new devices and expanding memory in a way that's much more efficient than kind of shoehorning it into PCIe. And you'll see when I talk on the next slide how this enables the CPU and an accelerator, for example, to share resources a lot more efficiently. In the CXL specification, we talk about some representative usages. And I say representative because honestly, we're not sure what kinds of new imaginative devices the industry is going to come up with, but we think it's going to be devices that are roughly in these categories. I'm sure there's going to be a lot of stuff that is even more interesting that we haven't quite thought of yet. In the middle of these pictures, you see the little box that says protocols. And that kind of shows you what these new CXL protocols are that run over the PCIe electricals. They're called CXL.io, CXL.cache, and CXL.memory. And the device types here combine these protocols in different ways. You can see the first two devices here are accelerators. The main difference being that the one in the middle has a bunch of memory also attached to the accelerator that, again, both the host and the accelerator have access to. So that's kind of the exciting aspect of it. The CXL.cache is a cache coherent cache. It can participate in the system's CPU cache hierarchy, making it a very powerful protocol. I'm in the Optane group, and so where I believe Optane has a place on all three of these models, including accelerators. I largely focus on the right-hand picture, which we call a Type 3 device, and that allows you to expand the system's memory by building these Type 3 CXL devices. And I'm going to deep dive into that just a little bit. So Optane and CXL, I've got to say, are like made for each other, right? It really pulls together quite nicely. If you've ever heard me talk about persistent memory, you've seen this little diagram on the lower right of the slide that talks about the SNIA standard that we came up with. And you know that I would never allow anything in the world to break that programming model. Well, of course, if you have a program that is written to use persistent memory, it follows the programming model. If it was written for our first generation, codenamed Apache Pass, that was shipped now 2 years ago, if you have that program working today without modification, that same binary, without even recompiling, that program is going to work on CXL attached persistent memory. And that's because we follow exactly the same programming model. We do not break that. It's very important for us that applications who have done the work to leverage persistent memory continue to see the benefits and in fact improve as they encounter newer generations. Or even applications that haven't been modified to use persistent memory and they're just using Optane transparently. For example, our memory mode is a transparent mode to applications. The applications haven't been modified at all. And again, that's going to work just fine when we move to CXL. Only as Kristie showed in an earlier picture, now instead of the tiering happening between DDR on the DDR bus and Optane on the DDR bus where they're sharing, we now with CXL can split those two tiers. So DRAM has the DDR bus all to itself. Optane has CXL, and now we get concurrency, those two things operating at the same time where we didn't have it before. So we should see some great improved performance by splitting that apart. And again, this transparent use case just becomes that much better. As Kristie mentioned, CXL 1.1 is the stuff we'll see emerging on the first systems that support CXL. Then we'll see 2.0 show up shortly after that. I was part of the group that added support for PMEM and other types of memory to the CXL 2.0 specification. We did that back in November 2020. We got that published. And then we started encouraging operating systems to do the appropriate enabling for 2.0. I'm happy to say that's on track. It's actually going really quite well. It's they have a lead in front of the hardware, which is what you want. If you're so inclined, you could go look at the Linux kernel on kernel.org, and you'll see that much of the CXL 2.0 enabling is already upstream, ahead of the hardware showing up, which is really great to see. Bottom line is that software that has been optimized to use Optane, it's getting some benefit from Optane today. It's going to see improved performance when we move to CXL because of the splitting between the DDR and the CXL buses, and improved flexibility because of all the new types of devices and protocols that are available on CXL, and features that DDR's never had, like hot plug and things like that, pooling, things like that. So we're pretty excited about that. Just to dive into that even a little deeper, if you look at how all these components work together, CXL, Xeon, Optane, we really feel like this is a perfect match. Of course, it's designed to be that way. There's a lot of efficiencies that Intel, as the designer of the Xeon, as a participant in the CXL consortium, as the designer of Optane, a lot of efficiencies we can add and test and make sure that these things are all validated well together. I think we're going to see some very interesting devices emerging on CXL as people come up with new ways of combining these protocols along with GPUs and FPGAs and persistent memory. So that's pretty exciting. I like to see that we're building on PCIe. I think you're going to see machines have slots that look like PCIe slots, and sure enough, you can put PCIe cards like SSDs in there, or you can put CXL cards in there. So I think that's going to be a very flexible, powerful model. I think I've already driven home my point about the programming model not changing and some of the other improvements we've made. But let me just do a quick call out on the future of CXL. I've continued to be active in the CXL committee along with a lot of other companies where we're working on the next major revision of the spec, CXL 3.0. None of that is public yet because it becomes public when the spec is released, but that should be coming up in not too much longer. And I'm very excited about the evolution that we're doing of the 2.0 ideas, like around shared memory and pooled memory and tiered memory. It's got a lot of excitement going on around it by a lot of companies. So I think CXL has a lot of headroom, a lot of exciting future technologies coming our way.
That's good. So just picking up on the theme around the software enabling, I wanted to reflect on just the amount of enabling that we've already been doing and are continue to do to try to mature this ecosystem around data tiering and with the new memory models that Andy just went through. And I personally know from the NVMe enabling experience just how long it takes system and software architectures to change and adopt to a new tier being available and getting and extracting the value out of those new capabilities. It takes time, it takes planning, and it's one of those things where you have to start today to really be able to get there if you want to be there when CXL and these new products are available. And so all of the analysis and the characterization and the optimization, that's sort of reflected in this slide and that's ongoing, that's not even on this slide yet. These changes are going to carry forward to that CXL-enabled world and just get better, So our enabling work to date has covered a few different usage models, kind of broad usage models. We're enabling faster storage in appliances and HPC. We're expanding memory for better TCO and scaling up infrastructure. And then we're accelerating performance really well. These larger growing data sets and databases and big data analytics and AI are coming and getting ready or catching up to getting ready for the continuing explosion of data. We've been focused on partnering in our collaboration with ISVs and vendors that have publicly available products, a lot of the ones that we very commonly come and talk at these field days about. But we also work with larger cloud customers for some of their more kind of custom infrastructure use cases. And so I'm really excited today because we're here to share two of those more customer cloud use cases with you. These partnerships are sort of deep collaborations that last for a while to really work together and make sure that we have the best system and the best solution for them. And so one is a recommendation system usage with Meta. So it's kind of the light blue there in that AI analytics column. They recently shared their tiered memory work for their deep learning recommendation system via OCP this fall. And our Optane SSD serves as a very valuable slow memory tier that enables scale-up performance for multiple models and power savings, some pretty significant power savings. And then the second one is a collaboration with Alibaba in creating and deploying a piece of software called CXL, that's on the far left. CXL is a cloud storage acceleration layer. And in Ali's D3C instances, they're using this today. The software kind of smartly places metadata and buffers random access to enable high capacity storage, so getting that higher capacity at high performance and low latency. And the good news is that even though this has been a collaboration specifically starting out with Alibaba, CXL will be openly available for customers via integration into Intel's SPDK, which means that even more AI and big data analytics workloads can take advantage of this much needed higher capacity, lower cost storage at the performance that they really need. And so as we've been highlighting through the last 30 minutes, even listening to the Intel crew, all of this effort and this thought leadership going into these Optane-based solutions, it's going to enable our partners and our customers, the consumers of this, to be those first movers with the CXL technologies.